Hello everyone, and welcome to the 100th WatchMeDoMath video. It's been exactly 23 months since I published my first video on Further Pure Maths, and that was when I was in year 11 and still doing that exam in the first place. It was published on January the 20th, 2019, after my friend told me that I should start a YouTube channel due to something we were doing in class, so you know who you are, I'm ever grateful for that. And over the 2 years, I've produced many videos, not only on this exam, but more recently on various topics in both maths and physics that I've been interested in and wanted to share with you guys. So, without further ado, let's get into the main show for today's video, which is I'm going to be sort of returning to my roots after 2 years of learning maths beyond the Edexcel IGCSE Further Maths syllabus. As an IB student, now in my final year of secondary school and soon to be going into university, we're going to see how I can deal with that kind of further pure exam. This is a past paper I haven't done before, and see how fast I can do it. This is not an educational video. You probably won't learn much by watching this, but it should be entertaining enough. And I'm going to be trying to complete this paper as fast as possible. The stops are off. I'm allowed to use any technique I learned during IB Maths, no matter if it's in the Further Pure syllabus or not. As you can see, I've got my professional gamer speedrun timer on the bottom right-hand corner of the screen, and we're going to be seeing the time it takes me to do each question with this tracker. So without further ado, many thanks to all of you who are watching WatchMeDoMath. In the past 2 years, you've brought me from very few to over 200 subscribers, and my videos have reached over 10,000 viewers' eyes. So let's begin. Yeah, it's something that's made me very happy and satisfied to do because I like teaching and I like feeling as if I can help people. So thank you all for watching again. It genuinely means a lot to me when people watch these videos, and I appreciate the fact that I can share a lot of the stuff I learned with other people around the world. Okay, that's sort of my emotional speech making done. Let's begin. So, the points A and B have coordinates 5, 9, and 9, 3 respectively. The line L is the perpendicular bisector of AB. Find an equation for L in the form ax plus by plus c is 0, where a, b, and c are integers. Okay, so if we sketch this out, we have 5, 9, and 9, 3. And it goes across by 4 and down by 6. Therefore, the gradient is delta y over delta x, which is negative 6 over 4, is minus 3 over 2. So that means, for, say, this point, 9 equals 3 minus 3 over 2 plus c, if we want y equals mx plus c form. Or rather, no. 3 is 9 times minus 3 over 2 plus c. 3 is minus 27 over 2 plus c. This is 6 over 2. Therefore, c is 33 over 2. C being 33 over 2, we get the whole equation of the line y equals minus 3 over 2x plus 33 over 2. If we just check with the 5 and 9, putting 5 in, we get minus 15 over 2x plus 33 over 2. And this... Well, anyway, we can just see what happens if we extend the line backwards. So if we go up 6 again, then we get 115. Yep, and then another 3 over 2, we get 0 and 33 over 2. So anyway, checking with 5, we get minus 15 over 2 plus 33 over 2, which becomes 18 over 2, or 9, which is exactly what we want. So we know that this is the correct form in y equals mx plus c form. So if we zoom in and do a little bit of working here, let me check that's all visible on the screen. Yeah, so 2y equals minus 3x plus 33, multiplying everything by 2, or we get in ax plus bx plus c equals 0 form, 3x plus 2y minus 33 equals 0. And that's our final answer. Where a, b, and c are integers, yep, 3x plus 2y minus 33 equals 0. And we can see this with any of the points we have here. 15 plus 18 minus 33 is 0. 27 plus 6 minus 33 is 0. So that's question 1 done. And you can see I've ticked that off in the speedrun timer over there. The volume of a right circular cone is increasing at a constant rate of 12 centimeters per second. The radius of the base of the cone is always half the height of the cone. Find in centimeters per second the exact value of the rate of increase of the height of the cone when the height is 4 cm. So we want dh over dt, where h is 4. And so let's try and find everything in terms of the height. Radius of the base of the cone is always half the height of the cone, so this is h over 2. The volume of the cone is 1/3 times the height times, let's see, the base. The area of the base is pi r squared, so pi h squared over 4, or is 1 over 12 h cubed pi. If we know that dv by dt is 12 all the time, and we want dh by dt in terms of h, then what we're going to have to do is multiply by dh over dv. And how do we find dh over dv? Well, we can find dv by dh by differentiating this with respect to h, so dv by dh is 1 over 4 h squared pi. That means dh by dv is 4 over h squared pi. Therefore, dv by dt times dh by dv is dh by dt is 4 times 12, 48 over h squared pi. And when h is 4, that becomes 48 over 16 pi, or cancelling out the factor of 16 here, we get 3 over pi. Does it ask us to any decimal figures? Nope. So this is a final answer, 3 over pi centimeters per second. So, yep, that seems correct. Let's move on. Question 2 done. Solve the equations. X squared plus xy minus 3x is 2. 5y plus 6x is 22. Okay, so what I think we can do here is firstly factor out the first equation to put an x here to make it simpler to calculate later. X plus y minus 3 times x is 2. And secondly, 5y plus 6x is equal to 22. If we were to find a value for y in terms of x, then we could substitute that into the first equation and it would be easier to solve. So let's try and do that. 5y equals 22 minus 6x. Y is 22 minus 6x over 5. Substituting into the first equation, we get x times x plus 22 over 5 minus 6 over 5x minus 3 equals 2. Simplifying the factor over here, we get x minus 6 over 5x is minus 1 over 5x, and 22 over 5 minus 3, which is 15 over 5, is 7 over 5. And this overall is still equal to 2. So if x times that is equal to 2, we bring it out. 7 over 5x minus 1 over 5x squared is 2. Multiply both sides by 5, we get 7x minus x squared is equal to 10, or x squared minus 7x plus 10 is equal to 0. This factorizes into x minus 2, x minus 5 is equal to 0, or x is 2, 5. Subbing that in, back to our expression for y, when x is 2, we get y is equal to 22 minus 12 over 5, which is 10 over 5, which is 2. Or when x is equal to 5, we get y is 22 minus, well, 6 times 5, 30 over 5, which is minus 8 over 5. And our final answers are x, y are equal to either 2, 2, or 5 minus 8 over 5. And just checking with our original equations, 2 and 2, do they go in here correctly? Yes, we get 10 plus 12 is 22, sounds good. And then 5 minus 8 over 5, so we get 25, and 6 times, oh no, this is minus 8 over 5, goes into y. So minus 8 plus 6 times 5 is 22, right? Second equation holds true. First equation, 2 and 2, we get 4 plus 4 minus 6 is 2, sure. Or 25 minus 15, 10, plus x times y, which is minus 8, 10 minus 8, 2. Okay, sounds good. I'm confident in these answers, so I'm going to box them off as our final answer. And now we move on to the next question. Question 4. Figure 1 shows the sector of circle of radius 10 cm and center O. The area of triangle OAB is 20 centimeters cubed, 20 centimeters squared. Radius is 10. And the size of angle AOB is theta radians. Find three significant figures the value of theta. Okay, so what's the value of theta? How do we go about this? OAB, 20 centimeters squared. A is half AB sine theta, or in this sense it's half times 10 squared, the radius, sine theta, meaning that 20 is half 10 squared is 50 sine theta, or that sine theta is 2 over 5. Putting this into my calculator, trying to find arc sine, or rather sine to the negative 1, menu, run matrix, shift sine, arc sine 0.4, which is 2 over 5, we get 0.412 radians, or 0.41151684661. Find the length of the arc AB. So we take our L is equal to theta R equals the answer times 10 equals 0.4115 times 10. And rounding to three significant figures, we get 4.12 centimeters. And that's the length of the arc. So find the area of the shaded segment. Well, to find the area of the shaded segment, we want to subtract the area of that triangle from the area of the entire sector. The area of the entire sector is theta r squared over 2, or 50 theta, because r squared over 2 is 10 times 10 to 100 divided by 2, 50. So 50 theta minus 20. 50 times 0.4115 minus 20, as put into the calculator, is 50 times answer minus 20 for that final area, which is 0.57584 0.57584 to so on, so on, so on, is 0.576 centimeters squared. Right, so that is question 4 done. Yep, I'm fairly confident that's the right answer. The area of this triangle is 20. The area of that whole sector is going to be around just over 20. Yep, sounds good, because 0.4115 is a pretty small angle anyway. Right. I'm going to consider this done. Now we move on. A curve C has equation y is 2x minus 5 over x plus 3. Find x is not equal to negative 3. Okay, as x goes to infinity, it would... 2 infinity minus 5 is 2 infinity. Let's just write this out, actually. Parallel to the x-axis, so we want horizontal. 2 infinity minus 5 over infinity plus 3 is 2 infinity over infinity is 2. Therefore, the horizontal asymptote is y is equal to 2. So this is taking a really big value. If you took a really small value, you'd find the same thing. It would be minus 2 infinity over minus 2 over minus infinity, getting you 2. So y is 2. Parallel to the y-axis, x cannot be negative 3. The asymptote must be x is equal to negative 3. Find the coordinates of the point where C crosses the x-axis. Crosses the x-axis, that means y is equal to 0. 2x minus 5 is equal to 0. As the denominator factor cannot ever be equal to 0, that means 2x is 5, x is 5 over 2. Coordinates of the point means that we must give it in the form 5 over 2 comma 0. And for part 2, crosses the y-axis. In this case, x is 0, so we get y is minus 5 over 3, or the coordinate 0 minus 5 over 3. And that's just mentally removing the x terms from this whole equation, 0 minus 5 over 0 plus 3. Sketch the graph of C, showing clearly its asymptotes and the coordinates of the point where the graph crosses the coordinate axes. Okay, so, yep, we have a little bit of space here. Apologies for the interruption. You'll see the timer's just suddenly been stopped a few seconds later. That was because someone came into my room. I'm going to continue now. Resume. Right. So we have this point, minus 5 over 3 and positive 5 over 2 as intercepts, meaning that we get this if y equals negative 3 is the vertical asymptote, and you've got a negative y-intercept, it suggests that the whole thing is slightly underneath the horizontal asymptote for the whole time. I'm just thinking this through. At a large value of x, so for instance at 1,000 we'd get 1995 divided by 1003. Yep, that would be slightly less than 2. I can see where this graph is coming from. So we have this vertical asymptote, x is equal to negative 3, and a horizontal asymptote, x is equal to, y is equal to 2. And we have a graph that looks like this passing through this point. So the limits of the pen tablet are really showing here. X equals minus 3, y equals 2, this kind of graph. Cool, cool, cool. So that's the sketch done. Find the gradient of C at the point on C where x is equal to negative 1. Okay, so this looks like some kind of differentiation question. We have y is 2x minus 5 over x plus 3. We want y prime, and using the quotient rule, if y is u over v, then u over v prime is u prime v minus uv prime all over v squared, which would be, well, u prime is 2, v is x plus 3, minus u, 2x minus 5, v prime, which is just 1, all over v squared, x plus 3 squared. So if x is negative 1, you get 2 and 2 minus negative 1, so this is negative 7, this is 1, and then 2 squared on the bottom. So we get 4 plus 7 divided by 4 is 11 over 4. That's the gradient. Cool. So that's question 5. I'm going to consider it done. A rectangular sheet of card measures 80 cm by 40 cm. A square of side x is cut away from each corner of the card as shown in figure 2. The card is then folded along the dotted lines to form an open box. The volume of the box is v centimeters cubed. Show that v is that. Okay, so I'm going to annotate the figure here. That means this side would be 80 minus 2x, and this side would be 40 minus 2x. And the whole volume of the box, v is width times length times height, which is going to be equal to, well, width, length, and height are all arbitrary measures, but substituting in what we found out from looking at the diagram, 40 minus 2x, 80 minus 2x times height of x. So this becomes 3200. I'm taking the first and then outer and inner. We want minus 160x and then minus 80x, so minus 240x. And minus 2x times minus 2x is plus 4x squared. And then all of this times x for the volume, meaning that we get an overall answer of 3200x minus 240x squared plus 4x cubed. And that's our volume. Find three significant figures, the value of x for which v is a maximum, justifying that the value of x gives a maximum value of v. Okay, I'm just going to drink some water because I'm out of, my throat is so dry. Right. Okay, so if we differentiate this once, dv by dx, we get 3200 minus 240x plus 12x squared. We want dv by dx is equal to 0, so 3200 minus 240x plus 12x squared equals 0, or dividing everything in this equation by 12, 3200 divided by 12, oh, that doesn't even work, does it? So what do? We divide by 4, maybe? 800 minus 60x plus 3x squared equals 0. How might we factor this out? Well, I'm not sure if it's even possible because we want 2400 and then a difference of 60. Yeah, no, I'm not sure if there's going to be an integer solution for this, so I'm going to plot it on a graph and look for the minimum using a graphical analysis of the mighty GDC. Or actually, no, I'm just going to solve the equation on the equation solver. Very easy. So if I go solver, equation, select type, polynomial, degree 2, a is 3, or just to be safe, a is 12, b is minus 240, c is 3200. And this should be 480x. This should be 120. My mistake. Yeah, that doesn't really help us. Minus 480. Solve. Yep, okay, that explains it because there are two minima, it seems. One at... Okay, so if I say... Pen's not working. If I say solved with GDC, x is equal to 8.4529 or 31.547. And then this is invalid as x must be less than 20 by the physical limitations of the box. Because if x was more than 20, then obviously there would be no box left on the sides. We would just have a sheet of cardboard again. Nothing to fold up. So that means x is 8.4529 centimeters. And since we found this value of x for which v is a maximum, we want to justify that this value of x gives a maximum value of v. So justification, d squared v by dx squared would be, from this equation here, 3200 minus 240x minus 480x plus 12x squared, we get 24x minus 480. And yeah, 24x minus 480 when x is around 8.5, then we get 24 times 8.5 minus 480. Actually, no need to do all this. When x is 8.4529, d squared v over dx squared is equal to, we pull out our run matrix again, 24, 8.4529 minus 480 is, we do this calculation, we get 8.4529 minus 480, we get minus 277.1304. Therefore, as the second differential with respect to x is negative, therefore v is at a maximum at this value of x. So that's our justification. Now we go to part C, find to three significant figures the maximum value of v. Oh, and also we want this to three significant figures, so we say x is 8.45 cm to 3sf. Maximum value of v. Well, putting that into the original equation, we get 40 minus 2x, 80 minus 2x, x, when x is equal to 8.4529, v is equal to, so if I just store this as a variable in my calculator, I've forgotten how to, oh, okay, you can just put an arrow, that should work. Right, so we want, stored it as variable a, so 40 minus 2a times 80 minus 2a times a is 12,316.80574. Or to three significant figures, v is 12,300 centimeters cubed. And that's our final answer. Very, very cool. So yeah, 80 minus 2x, 40 minus 2x, and x as the height. Sounds good. I'm going to consider question 6 done. Now moving on to question 7. Figure 3 shows this prism, abgefigurhij, which consists of a triangular prism, abgefigure, on top of a cuboid, bukadefhij. P is the midpoint of DC. Calculate in centimeters to 3 significant figures, length of PG. So what is PG? Here. We want this line. So, side view of the plane. Well, what's another point on this plane? PAG. We have P, A, G, and an unlabeled point here. And we know that AG, well, what is AG? It's a prism, therefore it's going to be the same as BHCI, DJ, EF, and AG. Therefore, as it's a prism, it's 15 cm. And what about AP? Oh, damn, I actually have to do some math here. For AP is, well, let's take a look at this. AEB, call this X. We have 5, 5, 8. That means there's 4, 4. Given that this is a Pythagorean triplet and this is a right angle, we've got some value 3. This height 10 adds to that 3, making AP be equal to 13. Therefore, PG squared is 15 squared plus 13 squared is 394, or PG is 2 3 significant figures, 19.849, wow, that's really close, 19.8494332 is equal to 19.9 centimeters. What next? The length of AC. Okay, so firstly, AC is going to look something like this, where this is 4 because it's half of DC. Then AP is 13 as calculated earlier. This is 3, 4, 5, 10. 10. Therefore, AC squared is equal to 4 squared plus 13 squared, which is equal to 16 plus 169. 185. AC is root 185 is 13.6 centimeters, almost exactly. Very good. Find in degrees to the nearest tenth of a degree the size of the angle between PG and the plane CDJI. Okay, so this is, if we look at the rectangle from before, we had AGP, and this is the plane CDJI. That means we just want this angle. So if this side is 13 and this side is 15, let's call this theta. Therefore, theta is arctan of 13 over 15, as this is the opposite over the adjacent, so katoa. So in degrees, changing the setup of my calculator to do degrees, we get tan negative 1, 13 over 15. Is 40.9 degrees. Cool, and for the size of the angle between, let me just check, CDJI, yeah, I'm 100% sure of that then. The size of the angle between the plane AGIC and the plane CDJI. AGIC, CDJI. Yep, if we look at the previous diagram, plane AGIC, plane CDJI. And we want this angle theta. And obviously we know that this side is 4 from previous calculation, this side is 13 from previous calculation, and similarly theta is arctan 13 over 4 is, let's calculate that using the calculator, 13 divided by 4, arctan 13 over 4 is 72.9 degrees. Cool, cool. So that's question 7 done, and now we move on. Question 8. Figure 4 shows hexagon OABCD. Each internal angle of the hexagon is 120 degrees. OA is AB is ed is 2 times OA, and OC is 3 times OA. No, I'm just kidding. I'm just messing with you. I'm saying these vectors in a very unserious manner. OA is A and OE is E. OA is OE. So the length of these is the same. AB is 2 times OA and OC is 3 times OA. Interesting stuff. Okay, so intuitively, I want to say that it's made of sort of, how might I draw this out? It's made of a bunch of triangles that are connected in sort of this way. Yeah, that's kind of what I am looking for. Find as simplified expressions in terms of A and E, AB, and BE. Each internal angle of the hexagon is 120. So first things first, as internal angles 120 and magnitude of A is equal to magnitude of E, and OA is 2, this is 2E, and AB is 3A is 3E. It can be divided into 1, 2, 3, 4, 5, 10 equilateral triangles as shown. Okay, so how would we find A? In terms of A and E, we want AB. So it looks like we're going to be seeing E, A, 2E plus 2A. And in terms of A and E, we want BE. Looks like Well, EB is AE, 2AE, okay, A plus E, 2A plus E, 3A plus E. 3A plus E is EB. That means BE is minus 3A minus E. The point P divides AB internally in the ratio 2 to 3. Find PC as a simplified expression in terms of A and E. 2 to 3. So it looks something like this, where this is P. In terms of A and E, we want, what do we want? We want PC. So PC is 3 over 5 AB, 3/5 of AB this way, followed by an E this way. Three over 5 AB plus BC is well, BC is just E. So this is this is 6 over 5 plus an entire E. 11 over 5 E plus 6 over 5A. Cool. And the point Q lies on ED produced, so that the points P, C, and Q are collinear. So some Q here, and some PC going down to Q here. I'm not sure if that's visible on the... Oh, yeah, I can see it's not visible on the video. I'm just going to move it so you can see. That's basically what I'm looking at. Right, so these are collinear. Find OQ in the form lambda A plus mu E, stating the value of lambda and the value of mu. OQ. And how many marks is this? That's 6 marks. Okay, I'm going to think about this for a minute. PCQ. So PQ is some mu times PC, and EQ is some lambda times ED. Where ED is something that we saw earlier, 2E plus 2A. And then OEQ is equal to OPQ. OPQ. Same sort of journey, same vector addition. Right. So if EQ is lambda ED, EQ is lambda ED, is lambda times, well, ED is basically 2E plus 2A. Is 2 lambda E plus 2 lambda A. And we want OE plus EQ to find OQ. So OQ equals QQ. OQ is OE plus EQ is E vector plus 2 lambda E vector plus 2 lambda A vector, which is 2 lambda plus 1 E plus 2 lambda A. So that's OQ. And secondly, we have OQ is OP plus PQ, which is some OP is OA plus AP plus lambda, not lambda, we need another coefficient, mu PC, which is A plus 2 over 5 2A plus 2E plus mu times, well, PC is 11 over 5E plus 6 over 5A. This is actually a really hard vectors question. I'm not sure why it's an FP. It's crazy, man. Like, okay, never mind, whatever. So we have A plus 4 over 5, A plus 6 over 5 mu A plus 4 over 5 E plus 11 over 5 mu E. So OQ is 1 plus 4 over 5, 9 over 5 plus 6 over 5 mu A plus 11 over 5 plus 4 over 5, 11 over 5 mu plus 4 over 5 E. And these two things are equal. They're made of two basis vectors, the same basis vectors, and we are giving them these coordinates in sort of a kind of coordinate space where instead of I and j we're using A and E to describe every point on the 2D plane. So that means we have a first equation in terms of the coordinate in A. 2 lambda is 9 over 5 plus 6 over 5 mu. 2 lambda is 9 over 5 plus 6 over 5 mu. And secondly, in terms of E, 2 lambda plus 1 is 11 over 5 mu plus 4 over 5. Right, so two fairly complex simultaneous equations for this kind of question, which is ever so slightly annoying. So obviously the thing that appears to me as most obvious to do is to subtract one from the other. Subtract 1 from 2, getting rid of this 2 lambda term. So 2 minus 1, that gives us 2 lambda plus 1 minus 2 lambda is just 1, is equal to 4 over 5 minus 9 over 5 is minus 1, and 11 over 5 mu minus 6 over 5 mu is mu, or mu is 2. Very easy. Okay, that was not as complicated as I thought it would be. And then, back into 1, we get 2 lambda is 9 over 5 plus 6 over 5 times 2, or 2 lambda is 9 plus 12 over 5 is 21 over 5, or lambda is 21 over 10 is 2.1. So just checking by putting it back into equation number 2, 2 lambda is 21 over 5 plus 1 is equal to 11 over 5 mu, so 22 over 5 plus 4 over 5. And if this is 5 over 5, it's quite clear that it's obviously correct because both sides are 26 over 5. And that makes me confident in my final answer, giving mu is 2 and lambda is 2.1. So what was the original question asking for? It was asking for find OQ in the form lambda A plus mu E, stating the value of lambda and the value of mu. So therefore OQ is equal to, well, mu is 2, so it's easiest probably to start with this side. 9 over 5 plus 6 over 5 mu is 21 over 5 A total, and 11 over 5 mu is 22 over 5, and 4 over 5 is 26 over 5 total here. So 21 and 26 over 5 of each vector. So OQ is 21 over 5A plus 26 over 5E. Just checking that's correct. Yep, seems like it. And now let's move on. show that the first four terms of the expansion, oh my god, first four terms of the expansion 1 minus x to the power of negative k is not equal to 0. Extending powers of x can be written as this. Using the binomial expansion formula, we get 1 minus x to the negative k as 1 plus x to the n, absolute value of x less than 1, is 1 plus nx plus n minus 1 x squared over 2 plus n minus 1 n minus 2 over 6 x cubed as the first four terms. And this is equal to 1 plus, well, n is minus k minus x plus minus k minus 1 over 2 x squared over the minus x squared plus minus k minus 1 minus k minus 2 over minus x cubed over 6. I'm seeing a pattern here, and that's that all of these minus terms will cancel out. So we've got two minus 1 terms here, and they're all going to cancel out to a positive 1, so it's 1 plus kx. We've got 1, 2, 3, 4 minus terms in this one. They're all going to cancel out, and we get k plus 1 over 2 x squared. And here we've got 1, 2, 3, 4, 5, 6 minus 1 terms, which all cancel out because you multiply minus 1 to the power of 6, you get positive 1 to find k times k plus 1 times k plus 2 over 6 x cubed. So show that this is possible. Yep, shown it. That was comically bad. Okay, lessons learned. Don't try to box with a digital pen tablet. Doesn't work. QED. Now what next? Expand 1 plus kx to the 1 over 2. K is not equal to 0, ascending powers of x up to and including the term in x cubed, simplifying your terms. So B, we have 1 plus kx to the power of 1 over 2. Okay, so this would be 1 plus nx, so 1 over 2 kx, plus n minus 1, so that's 1 over 2 times negative 1 over 2 is negative 1 over 4 over 2 x squared, so k squared x squared, plus, and let's see this, 1 plus kx to the 1 over 2. 1 over 2 times minus 1 over 2 times minus 3 over 2, which is the n minus 2, will get you 3 over 8 as a positive number, and that's all divided by 6. K cubed, x cubed, because we're cubing kx, and this is all equal to 1 plus kx over 2 minus k squared x squared over 8. Plus, well, 3 and 6 cancel down to just 6 on the bottom being 2, plus 1 over 16, or k cubed x cubed over 16. So that's our answer for B. Given that the coefficients of x squared in the two expansions are equal, find the value of k. Okay, so the coefficients of x squared are going to be minus k squared over 8 and k times k plus 1. And that means minus k squared over 8 is equal to k times k plus 1 over 2. Multiplying both sides by 8, we get minus k squared is equal to, well, k times k plus 1 becomes k squared plus k, and then times 4 we get 4k squared plus k. So 0 is 5k squared plus k. That means k could either be 0 or k, 5k plus 1 is 0, k is minus 1 over 5. As k has been stipulated not to be equal to 0. Given that 15 is lambda 3 over 5, find the value of lambda. Okay, I'm feeling like this is some kind of... I'm not sure what to think of this. Oh yeah, no, so it's just an algebra question, there's nothing deeper than that. Root 15 is root 3 over root 5 lambda. So running this out, we get root 3 root 5 is equal to root 3 over root 5 lambda. So root 5 is equal to lambda over root 5, multiply both sides by root 5, we get root 5 times root 5 equals lambda, lambda equals 5. And hence, using your value of k and one of your expansions with a suitable value of x, obtain an approximation for root 15. So therefore, root 15 is 5 times root 3 over 5. This is part E. 3 over 5 is an easy number to think about in terms of probably using the second expansion would be more convenient because it's less complicated. And we already have put the power in there. So, in that sense, using a value of k is minus 1 over 5, and using a value of x is, say, 2, we get 3 over 5 to the 1 over 2. So let x be 2, then 1 plus kx to the power of 1 over 2 is square root of 1 minus 1 over 5 times 2 is the square root of 1 minus 2 over 5 is the square root of root 3 over 5. Therefore, root 15 is lambda times, or 5 times 1 plus kx to the 1 over 2, which is 5 times, well, you have 1 plus kx over 2 minus 1 over 5, 2 over 2, minus k squared x squared over 8, I think. Yeah, so minus 1 over 25, 4, 8. So this goes to 1 over 50. This goes to minus 1 over 5. And this last term, k cubed plus k cubed x cubed, well, we're just looking for minus 1 over 125, x cubed is 8, and all this is over 6. So this goes to 4, 3, minus 4 over 375. I think. And then multiplying it out is equal to 5 minus 1 minus 1 over 10 minus 4 over 75. And putting that into a GDC, we get 5 minus 1 minus 0.1 minus 4 divided by 75 is 3.84666666. Obtain an approximation for root 15, and say to three significant figures it's 3.85. So let's see, we can check that very easily by just finding root 15. That's 3.87. Good enough for me. Let's, I realized what went wrong. That should be 16, because that was not good enough for me. I thought it was, but it wasn't. So this is more like 1 over 250, because I did the math wrong. That's 16. So we're left with a factor of 2 after cancelling out. So ignore all this stuff here. That's 1 over 250, and this is 1 over 50. So minus 1 over 10 minus 1 over 50, that's 3.88. That's our approximation, which is much closer to 3.872 than 3.85. Anyway, good stuff. Yep, I'm going to consider question 9 done. Sum of the second and third terms of convergent geometric series is 7.5. And geometric terms have the series geometric series have the terms un is equal to u1 r to the n minus 1. So second and third terms would be u1r plus u1r squared is equal to 7.5. Sum to infinity of the series is 20, so that u1 over 1 minus r is 20. So what do we do here? Common ratio of the series is r. Yep, sure. That's a convention. I've been using it already. Show that r is a root of this equation. Well, as term 2 plus term 3 is 7.5, then we get u1r plus u1r squared is 7.5, or u1 is 7.5 divided by r plus r squared. At the same time, as the sum to infinity is 20, we get u1 over 1 minus r is 20, or u1 is 20 times 1 minus r. As we have two values of u1, therefore 20 times 1 minus r is equal to 7.5 over r plus r squared. And how can we work our way out of these awkward coefficients? Well, if we divide both sides by 7.5, we get 8 over 3, because 7.5 is 3/8 of 20. So 8 over 3, 1 minus r, is 1 over r plus r squared. Or 8 over 3 times 1 minus r times r plus r squared is, it's 1. So multiplying everything by 3, we get 8. 1 minus r, r plus r squared is equal to 3. Or 8 times r plus r squared minus r squared minus r cubed is 3. Or just 8 times r minus r cubed is 3. 8r minus 8r cubed is 3. Let's see if that's the equation they wanted us to do. 8r cubed minus 8r plus 3 is 0. Okay, so putting everything onto the right-hand side, we get 0 is equal to 3 plus 8r cubed minus 8r. Therefore, 8r cubed minus 8r plus 3 is 0. Cool. So that's our polynomial found. Show that r is a half is the root of this equation. Sure. So we just need to show that the left-hand side is equal to 0 when r is 0. LHS is 8 times 1 over 8 minus 8 times 1 over 2 plus 3, which is equal to 0. Well, this is equal to 1, this is equal to minus 4, this is plus 3. 1 minus 4 plus 3 is equal to 0. Minus 3 plus 3 is 0. 0 is 0. Correct. Therefore, LHS equals RHS when r is 1/2. Therefore, r is 1/2 is a root of the equation. Cool. Given that r is less than 0.6, show that 1/2 is the only possible value of r. Okay, so what is suggested here? 8r cubed minus 8r plus 3 is 0. I'm thinking that there is likely to be some factor, maybe 2x minus 1, or 2r minus 1, I mean, in order for r equals 1/2 to be a root of the polynomial. So we can try and do some polynomial long division with 2 and minus 1 versus 8, 0, minus 8, 3. So let's try that. 8, 0, minus 8, 3. So polynomial division, 8, 0, 8, minus 8, and 3, divided by 2 minus 1, we get 8 and minus 4 with a factor of 4r squared. Subtract, and we get 4 and minus 8. Four and minus 8, that goes to, if we use 4 and minus 2, subtract, and we get minus 6 and 3. So 4, well, that's 2 here. Then minus 6 and 3, 2 and minus 1. Well, we get minus 6 and 3 as well by multiplying by minus 3. And then this is 0, and the remainder is 0. Therefore, 8r cubed minus 8r plus 3 is equal to 0. Is an equivalent statement to 2r minus 1 times 4r squared plus 2r minus 3 is equal to 0. And if we factorize that, we get, well, ab is minus 12, a plus b is 2. Do we know any numbers like that? Not particularly, so I think we're going to have to use the quadratic formula here, or complete the square. So 4r squared plus 2r minus 3 is 0. R squared plus 1 over 2r minus 3 over 4 is equal to 0. R squared plus 1 over 2r plus 1 over 4. No, I'm looking for 1 over 16. 1 over 16 is equal to, well, we have to go up by 13/16. And this works out to be r plus 1 over 4 squared is 13 over 16. R is plus or minus root 13 over 16 minus 1 over 4, which is equal to given that r is less than 0.6. Less than 0.6. Okay, my calculator is giving me some kind of quadratic equation style answer. which corresponds with what I would expect. B squared 4 minus 4ac minus plus 48. I think I'm going to use the equation solver because I'm not really trusting myself here. 4, 2, minus 3, solve, yeah. So this is either 0.6513 or minus 1.151, and this answer was correct. Invalid as r is less than 0.6, and this is invalid as the series converges, or must be greater than -1 and less than 1. So minus 1.151 is not possible. Therefore, r is equal to 1/2 is the only possibility. So we've established it's the only possibility. Now we must find the first term of the series, d. From before, we know that u1 is, what was it? u1 is 20 times 1 minus r, is 20 times a half is 10. And for the final question E, find the sum of the first n terms of the series is Sn. Find the least value of n for which Sn exceeds 99% of S. So basically we want Sn is greater than 0.2. Sn in any particular situation is u1, 1 minus r to the n over 1 minus r. Is greater than 0.2. So u1, 1 minus 1/2 to the n over 1/2 is greater than 0.2. Multiplying both sides by half, we get u1, 1 minus 1/2 to the n is greater than 0.1. If u1 is 10, then we get this has to be greater than 0.01. Or 0.99 needs to be greater, hang on. Okay, 1 minus 0.5 to the n needs to be greater than Is that the actual way to do this? Because I'm feeling suspicious about this whole thing. One minus r to the n over 1 minus r. Sn. Oh, I'm so... Okay, this needs to be greater than 19.8. Greater than 19.8. Greater than 19.8 for greater than 99%. Because of course it's going to be greater than 1%. It needs to be greater than 99%. So greater than 9.9, greater than 0. Greater than 0.99. This needs to be greater than 0.99, or rather 0.5 to the n needs to be less than 0.01. And by inspection, to find the least value of n, n equals 7. And why did I do this by inspection? Because I know that 1 over 2 to the 7 is 1 over 128, which is less than 1 over 100. So that's my final answer. And now I'm going to consider question 10 done. So after 72 minutes, we've done the question paper. Let's see how much I got correct. This is like, obviously it's way better than what I was doing when I was actually doing Further Pure Maths as a student. So it's kind of interesting to come back and see how these papers are like trivial for, not really trivial of course, because I was only able to do it in about 60% of the time rather than the whole time, right? I didn't even finish one of my papers when I was taking it in the first place, because it was incredibly long and computationally intensive. So let's see, 2x minus 3y plus 4. I'm actually stupid, like, that is quite silly of me. I found the line through these 2 points, but that's not what we're looking for. So let's see how many marks I get. Okay, I get 1 mark because I did not find the perpendicular bisector. So this is a 100% speed run, obviously, so I have to find the answer correctly. That means m perpendicular would be 2 over 3, and it would have to be through this point in the middle, which would be, well, 5 to 9, midpoint is 7, 9 to 3, midpoint is 6. 2 over 3 through 7, 6, means that 6 is 7 times 2 over 3 plus c, or 6 is 14 over 3 plus c, 18 over 3 is 14 over 3 plus c, c is 4 over 3. That means we get y is equal to 2 over 3x plus 4 over 3, or moving everything back to one side and multiplying by 3, minus 2x plus 3 minus 4 is equal to 0, or 2x minus 3y plus 4 is equal to 0. And that's our final answer. So is that correct? 2x minus 3y plus 4 is equal to 0? Yep, that's a 100% after corrections. Volume of a right circular cone is consistent. Okay, we want 3 over pi. Let's see. Come on, come on. 3 over pi. Hell yeah. Correct. 100% on this. And like, this marking segment is going to include me working through the problem again if I got it wrong. So I have an incentive to have gotten it right the first time. Let's see. 2, 2, 5 minus 8 over 5. Good. 100%. Zero 0.412, 44.12, and 20.574. Shade area 576. Right, so this is right, right, and right, 100%. And y is 2, x is minus 3. Yep, coordinates 5 over 2, 0, 0, minus 5 over 3. Yep. And the sketch, what do we need for the sketch? 2 branches in correct quadrants, asymptotes, crossing points. Yep, looks like that's all there. And for this last one, 11 over 4, 11 over 4. Yes, good job. 100%. Width, length, height, da, 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 da. Yep. Okay, my throat is really very sore after talking so much. It's gotten quite cold here in Hong Kong. It's getting very dry. So dv beta x is this. So, and we have this from calculator. So there's no need to M1 depth. Depth dependent? What does that mean? Am I not allowed to use the graphical calculator? Ah, cool, cool, cool. I am allowed to use the calculator. Epic. Okay, so these two roots, finding that the 3x squared minus 20x plus 800 and 12,300. So 12,300 at the end is correct. Second differential is negative, therefore v is a max of this x, correct justification, and correct roots. Therefore x is 8.45, excellent, 100%. Okay, so what's next? This geometry problem, we want 19.9 centimeters. 19.8! I'm clowning, I didn't round it correctly, ha! 19.8. Rounding. So this is another -1, but I'm gonna, not like that mistake obviously very easy to correct. So that's 19.8, then 13.6, good. Then arctan 13 over 15, 40.9, 72.9. Arctan 13 over 4. Cool, so that's 100% after some extremely silly corrections, and so far we've lost 5 marks on the first pass. So what's all this? AB and BE. This is where it's less how would I call it? Yes, less likely to be 100% correct in these last few questions because they are quite long. Need not be shown explicitly. Okay, thank goodness. Okay. 2a and e. Yep. Minus 3a plus e, so minus 3a minus e. Yes, good. PC is 6 over 5, 11 over 5. Fun fact, if you would like to watch my other video on basis vectors, you can see that this thing itself is 6 over 5 and 11 over 5. Let's see. You could write this as a sort of vector going through a linear transformation. So sort of multiplied by a matrix. This is kind of how linear transformations work. But anyway, 3 blue, 1 browns linear algebra series explains this kind of stuff way better than I do. But just for the curious, this is how you might write it if you were looking at a coordinate system in terms of a and e, like I was mentioning earlier in the video. Because that's why you can make these simultaneous equations and make these coefficients equal to one another. So, well, whatever the method we used, what's this? Okay. Yeah, maybe I should not have used lambda and mu in my actual working, but I still got there anyway, so 25, 21 over 5, 26 over 5. Correct final answer. I'm going to give myself all 6 marks because that's how maths should be. I'm just kidding, but like, if it's a linear question, you're looking for 2 values, then they're going to give you 6 marks if your method is valid. What? Must be simplified? Ridiculous. You're joking. Oh, or equivalent. Never mind, never mind. Yeah, so that's question 8, 100% on that. And question 9, using the binomial expansion, Yes, I'm fairly certain this is correct. Let's just see. Yep. And this is also correct. K is minus 4 over 5. What? Oh, good lord. That's so funny. Because they want you to use the value of K to continue, but I was still able to somehow do it. That's actually hilarious. K is minus 4 over 5. Well, I suppose that's true. You could do it with any value of K because X can be whatever value you want. Alright, whatever. I'm wondering if they will give me error carried forward. So, this silly mistake here brings you to, should be 4k squared plus 4k, 5k squared plus 4k, 5k plus 4, k is minus 4 over 5. So if you let x equal 1 over 2 instead, it's minus 4 over 5 times 2, 1 minus 2 over 5, Well, I'm basically doing the same thing, and I'm still coming to the correct estimate, so I'm going to give myself all the marks except 1, so minus 1 for an inaccuracy. And so far we're down to 6 lost marks on the first pass, and the estimate of 3.88 was correct. N is 7, A is 10, only possible, R too big, R here not convergent. Or by division, and then that's just calculation. So this is all correct, finding 2 expressions for U1. Left hand, right hand side. It's equal to 0, correct. Through polynomial long division, we find this. We find these 2 roots, invalid as too big, invalid as the series must converge, therefore R is 1/2 is the only possibility. Cool. U1 is 10, yes, and N is 7. Correct. Final answer. 100%. So, 94 out of 100 on the first pass is our final result for this paper. And that's the end of the marking and the corrections to give us a final time of 1 hour and 25 minutes. So, if you are still watching by the end of this video, what are you doing with your life? But also, thank you. And this has been an interesting experience to reflect a little bit, because firstly, it goes to show that no matter how good you are at math, the last like 5%-ish of an exam will always be super difficult to obtain, because you need to be extremely focused in making sure that you are not making any silly mistakes. So it is like a saying I often tell people is that the first 95% is skill, the last 5% is luck. And that's probably held true here. So I lost 2 to silly mistakes and 4 to simply not reading the question properly. I mean, I read it out, but I didn't comprehend it, you know? And another thing to note is that after doing this paper, it's interesting to see that it's still a little challenging, even as someone who's been doing the IB higher level maths papers for a while. So that's just pretty interesting to know. So hopefully you enjoyed this video. Thank you for sticking around for 100 videos of Watch Me Do Math, and here's to many more to come. Until next time, this has been Watch Me Do Math. Thank you for watching.